Okay, hello everyone. This video is going to talk about the centroid calculation. Okay, in the last video, we have shown you we introduced where is the center of volume formula comes from. Actually, from center of mass, and then we use concept to calculate the center of weight or center of gravity. Actually, and your material have the uniform density and uniform gravitational constant, the center of gravity just equal to the center of volume. Okay, that's for 3D case. Okay, and if we can reduce to 2D case, it will become centroid of area, because it becomes a centroid of area. Actually, it should be it's centroid of area. Okay, and the centroid of area, the formula is like this: is x doing integration with dA, tiny area, and divided by total area, and y and the centroid of the y component, centroid position of y, centroid position y, the y component of the centroid position vector. You are doing the integration of you are doing the y integration with dA and divided by total area. Okay, in the next video I say, okay, you can use this formula to determine the centroid of rectangular shape. Okay, but I think it's not necessary to that. I don't think it's really not really necessary to use this integration form to prove the centroid of rectangular area is b over 2 and h over 2. Yeah, that's very intuitive case, so I don't think you need to use the formula to prove this. But what I'm going to do in this video is the right triangle. The right triangle will use this a lot, and when trying to convince you, this formula can really help you to calculate the centroid of the right triangle. And then, after all, you have to remember the conclusion, or the way is the centroid of the right triangle. Okay, let's start with it. Okay, so for this 2D case, the centroid, we have this is the position of centroid. You have two coordinate, right? So you need x coordinate and y coordinate. So we are talking x bar and y bar. Let's start with x bar first. So let's start with x bar first. Okay, let's write the formula here. Okay, so the x bar is equal to total volume, 1 over total divided x integration with dA. Okay, when trying to find where's the position x coordinate of the centroid, okay, so we will make the slice like this. Okay, let's see, we'll make a slice like this. We divide it as a tiny slice on this area. Okay, there's a tiny slice on this area. Okay, suppose this is x plus dx. Okay, and the height here, we just say it's just a y. Okay, y. Okay, so the width of this, so we need dA. Okay, dA means tiny area of this tiny slice, and this A is total area. Okay, the total area is easy. Total area is equal to, okay, it's B times H over 2. Okay, I think that's no problem. And what is the tiny area of this slice? What's tiny area of this slice? Okay, so we know the width because we suppose this is a dx. The width is dx. Okay, no problem. It's dx. And what's the height? Okay, the height we choose the left hand side point. We just times the y. And what is y? Okay, because it already give you the right triangle, it already give you the height h and the base is b. Okay, so you can calculate the formula of this straight line. Okay, the formula of this straight line, yeah, I don't think I want to spend time on this. Try to calculate it by yourself. The equation of this straight line is, let me check my notes. Okay, it's y equal to b minus hx plus h. Okay, try to convince yourself the y, the line, the equation of this straight line is y equal to minus h over b times x plus h. Okay, so this is y, so we can switch the y here. Okay, we can switch the y here. So what is dA? The dA just equal to dx times minus hb over x plus h. So okay, so what's our dA? Let me write. We can just let us just rearrange this formula to much proper way. So it's dA is equal to b minus hx plus h dx. Okay, that's about dA. Okay, so we got everything together, so we can calculate what is our x bar. Okay, so the x bar, okay, it's 1 over total area. Total area is bh over 2. bh over 2. Okay, x dA integration is x. We don't touch it. dA is equal to b minus hx plus h dx. And what's the range? Because we integration with respect to x-axis. X-axis is from 0 to b. Don't forget the range is 0 to b. So, okay, what's the answer of this? I think it's very easy. BH2, okay, 0b. Okay, we have 2. B minus hx squared plus hx and dx. Okay, so the remaining part is the calculus problem, right? Okay, so I just do it quick way, okay, because I think it's easy. Okay, so let's see what the answer is. Okay, BH over 2. This is 2, okay, minus HB squared plus 2HB squared. So what's the final answer? BH2, so it's 6HB squared? Okay, so divided. So it's b over 3. Okay, so the x bar, okay, the centroid position, the x component of the centroid position, x bar is b over 3. Okay, that's the x bar. Okay, and let's do the same thing. What's the y bar? What is the y bar? Okay, for the y bar, we have to make another slice. Okay, so I have to erase this slice. So if you want to, so I have to erase this out. So please, rewind if you want to make a notes. So please rewind. Okay. Okay. So if we want to calculate the y bar, we need another slice. So how to calculate the slice? Okay, slice. You need another slide like this. Okay, suppose this is y. Okay, and here is your, I think it's same thing, is your x, and this is dy. Okay, let's start with it. So what's the y bar? Y bar is the same, 1 over a, 1 over a. Okay, let's start with y bar. Let's change it, just change it. We don't need to, what's the y bar? Okay, y bar, okay, it's y dA. Okay, a, same thing. Okay, so what about dA? dA is dy times the x, because right now our slice is here. So dy is here and x, so that dA is x times dy. So, okay, so erase this out. Okay, we don't have change much. That's very good. We don't change much. Okay. So it's x times dy. X times the dy. Okay. So, and what's the next thing is what is dy times what is x? Okay, because we add the volume, we add the tiny volume all the way up on the y direction. So our x is changing. Okay, our x is changing because we add the volume all the way up on y-axis. So our x is changing with y. So we need to try to find a relation between the x and x with respect to y, and then this tell, and that's why we need this equation again. Okay, this tell you how the change between the relationship between the x and y. And right now we are doing the integration on the y direction. So we need the change of x with respect to the y-axis. So with the switch, we have to make a little change. It's just tell you y minus h and hb my hb equal to x, right? It just tell you this. Okay, so what tell you? So that means x equal to h minus by plus b. Okay, so we have to use this x plugging in. So we have dA is equal to h minus by plus b and dy. Okay. Okay, we have to change the x with change of x with in terms of x by y. Okay, change x in terms of x by y. Okay, so we got everything together. So we use the formula to calculate the y bar. Okay, we'll pretty much the same procedure. Okay, so and we have to make a little adjustment here. Okay, and the calculation, yeah, it's a little different. Calculation is different. Okay. Okay. Okay, that's back to work. Okay, so we calculate the y bar. Okay, 1 over a is the same, bh over 2. And y, okay, doesn't move. Okay, doesn't move. And the y is equal to, and we have to switch dA. dA is yeah, minus b over hy plus b dy. So what's the answer is bh2. So okay, don't forget the range. The range is with integration along the y direction. So it's from z to h. It's from z to 0 to h, 0 to h. So let's see. What's this going? Okay, h minus by squared plus by dy. Okay, let's do integration. I just do a very quick calculation because it's easy, so you don't need to spend too much time on this. Plus b h squared. Okay, so what's the answer? Let's see. 2. So it will become 3, 6 bh squared, right? Okay, so cancel. So y bar is h over 3. Okay, so and then don't forget the conclusion on x bar is b over 3. Okay, so what's the conclusion? What's the centroid of right triangle? Okay, the centroid of triangle. Okay, here y bar h over 3, x bar b over 3, Okay, b over 3. It's here. X bar is here. Okay, y bar is here, h over 3. Okay, this is very important conclusion. I think you should memorize it because this will use a lot. So I don't think you need to prove this. I don't think you need to prove this every time. Okay, I don't think you need to prove this every time. So just memorize the results. The centroid of right triangle. Okay, the position, x position is b over 3. Y position is h over 3. Okay, height over 3. Okay, base divided by 3. Okay, so this is a very important conclusion, and we will use this for the next example for the composite area. So this you have to remember this. Okay, I just show you the centroid position of right triangle. Okay, 1 over 3. Okay, just memorize 1 over 3. Okay, this will use a lot. Okay, so We'll use this conclusion for next calculation, and I will demonstrate calculation next video. And this video I just stop here. Thank you for your watching. Okay, see you next time. Bye bye.